Oh, dag, you guys caught me doodling in class. Hint, hint, hint. Okay, let me get rid of this picture while I tell my favorite geometry. Okay, I can't. While I tell my favorite geometry students what's happening. Today we are working in chapter 6. Here we're working in section 6.6, and now this looks really bad. I was trying to make like a subtle, not subtle point. Okay, there. Hey guys, hey geometry friends. Here we are working in section 6.6. We're going to talk about trapezoids and kites, those other quadrilaterals that we don't usually discuss. Okay, so it's not that we don't discuss them, it's just that they're not really as popular as the other ones that we've talked about. They're not used as often, or at least as far as I would say. So what's a trapezoid? So let's get started talking about each of these guys. And we discussed a trapezoid last time we were together, looking at our family tree of quadrilaterals. And a trapezoid is a four-sided figure, a quadrilateral, such that it has exactly one pair of parallel sides. Only one pair of the sides are parallels. All right. And so one pair of sides are parallel. These are the sides. And these sides are actually called the bases. Okay. So this whole thing here, let me see if I can color code this in a helpful way. This whole thing that I'm highlighting in green is a trapezoid. That is what it is. And when we talk about the bases of a trapezoid, we're going to be talking about let's see, this section over here. The bases referred to these two sides that are parallel. They're called bases. All right. And the legs of the trapezoid are considered these guys that I'm going to mark here in purple, this side and this side. And a trapezoid actually has four base angles, two pairs of base angles. So these two are base angles and they're not necessarily equal, so I shouldn't do that. And then these guys are base angles too over here. I don't want to go too heavy on the curves here, but these are also base angles. And since they're not necessarily equivalent, I need to, do that. Isosceles trapezoid is a special kind of trapezoid. So we take our idea of trapezoid again, and an isosceles trapezoid is just what you think it is. It's a trapezoid such that its two legs are equivalent in length. So this doesn't look particularly beautiful, but an isosceles trapezoid will have the bases will be parallel and two legs will be congruent. And cool things happen when you're dealing with the isosceles trapezoid that we'll discuss as we get through more of our chapter. And the mid segment of a trapezoid refers to, let me draw a larger trapezoid here. So if I have this guy and here are my bases that are parallel to one another, the mid segment is going to refer to the segment that connects the midpoints of the legs. Boom. And so this would be the mid segment, and it would happen to be parallel, and we'll talk about that, and some other really cool results happen as a result of getting the mid segment of a parallelogram. And finally, of not mid segment of parallelogram, sorry, mid segment of a trapezoid. And finally we have a kite. And a kite, we know what a kite looks like, but how do we define it when we're talking about it in terms of a quadrilateral? Well, a kite is a quadrilateral where you have exactly two pairs of consecutive sides that are congruent, just as we've drawn here. So it has to have two pairs of consecutive sides that are congruent and not congruent to each other, meaning I can't have a situation where all of these guys are congruent, meaning according to our textbook is telling us explicitly that a kite cannot be a rhombus, because a rhombus has all the sides, like any two pairs of sides are congruent. In here, these are exactly two pairs of consecutive congruent sides or adjacent congruent sides. Are you guys with me? So that's what a kite is. So that's the definition of a kite, definition of a trapezoid, and let's go on to some examples. Just kidding, not examples yet. We're going to first get through some of these theorems. So here we have theorems about isosceles trapezoids. And remember, an isosceles trapezoid is a trapezoid where the two legs are congruent. And here's the first thing. If you have a trapezoid, if a trapezoid is isosceles, then here's what you get. You know that each pair of base angles are congruent. So these two guys are equal to one another, and these two guys are equal to one another. Just like the isosceles triangle, right? Remember the base angles of an isosceles triangle are congruent? Let's take a look at this one. 622, sorry about that. If a trapezoid has one pair of congruent base angles, then guess what? It's isosceles. It's an isosceles trapezoid. So you're walking down the street, you're checking out this trapezoid, you're like, hey trapezoid, it looks like your base angles are congruent. Guess what you can say? Ah, I see you're an isosceles trapezoid. Get it? Good. Section 623, or Theorem 623, a trapezoid is isosceles if and only if its diagonals are congruent. So this statement, if and only if, I made a little video about it that many people ignored, but if and only if is kind of like a backward-forward statement. So what it gives us the opportunity to do is say it one way. We could say, if you're walking down the street and you see a trapezoid in this isosceles, then you know its diagonals are congruent. If you're walking down the street, so here's the backward part. If you're walking down the street and you see a trapezoid whose diagonals are congruent, then you know it's isosceles. So it's almost like a revolving door of a theorem. It lets you come in at either end and get access to the other end, if that makes sense. Probably took that analogy too far, but I hope it made sense. All right, so here we go. We have a speaker here in example 1. The speaker shown is an isosceles trapezoid. And if the angle here, FJH, that's this guy, is 85 degrees, and FK, where's FK? I doth not see it. Oh, there it is, FK. If FK is 8 inches, and JG is 19 inches. They're getting real intricate here. 19 inches. Hopefully you guys can see that. Find each measure. So the first measure that we are supposed to find, I think I may have inadvertently deleted that. Let me go back real quick. One moment. Okay, I figured it out. We're supposed to find the measure of angle FGH. Given all this information. All right, so what I understand here is that if we are dealing with an isosceles trapezoid, there's some information that we can take for granted. And so one is, let's go ahead and redraw this really quickly. So one bit of information is that we know that it's an isosceles trapezoid so that the angles, the base angles, are congruent to one another. So if this is 85, this has to be 85, and we know that the sum of all the angles of a quadrilateral would be 360, so we know that that's going to be 360 minus these two 85s, which is going to be like 90 plus 90, which is, golly geez, Willikers, 180 minus 10, this is going to be 170. Sorry for taking so long with that. So when I subtract 170, I'm going to have to divide by 2 to get each of these angles. And that's going to pretty much answer this, right? So realize that all 4 of these add up to 360. If I subtract 170, which is 85 and 85 twice, and then I divide that in half, I'm going to get these angles up here. Hopefully that made sense. So 360 minus 170 is going to leave me, if I'm not mistaken, with 190. And when I divide 190 by 2, I end up with a 95. Which makes sense, yeah. So this is a 95-degree angle up here, and therefore this is a 95-degree angle up here. Therefore the measure of this angle has to be 95 degrees. Hopefully that logic made sense. And so the next thing we're supposed to find is KH. And so we read that one of the properties, and I can slide back here and remind us, it says that a trapezoid is isosceles if and only if its diagonals are congruent, right? So we said this if and only if statement goes back and forth, and then so it says if you got an isosceles triangle, then you have diagonals are congruent. If you got diagonals are congruent, then you know you got an isosceles triangle. Right now we want it to go this way because we've got an isosceles triangle, and I want to say, hey, then the diagonals must be congruent. Therefore, GJ has to be congruent to FK. And if GJ is congruent to FH, then I know that this whole thing is also over here. This is 19, right? This has to be 19. And if this is all 19, but I've gotten that F to K is 8, then I can subtract that. So let me write it down here. Oh, sorry about that. I know that FH, that's this segment here, is equal to 19. And therefore, F or KH, I'm making this take far longer than it needs to. KH is equal to 19 minus 8. I don't think I wrote this as elegantly as I would like to, but I hope you were following the reasoning. 19, 19, both of these have to be 19. If from here to here is 8, from here to here has to be 11. And that's where we got that from. Let's go ahead and take a look at this one. Isosceles trapezoid and coordinate geometry. So we have a quadrilateral ABCD, and here are the vertices. Show that this trapezoid, show that ABCD is a trapezoid, and determine whether it is an isosceles trapezoid. So they didn't even tell us we have a trapezoid here. They just said we had a quadrilateral. So to prove that it's a trapezoid, one of the things we need to do is prove that these guys are parallel. So I need to check the slope of BC and the slope of AD. If that's true, then I've got the first part of proving that this is a trapezoid. Recognizing that I'm trying to prove parallelness, I totally have to find the slopes. So I'm doing, for each of these, change in y over change in x, using the vertices up here. And I know you guys can follow along: 4 minus 0, negative 3 minus a minus 1, 5 minus 3, so forth and so on. 4 minus 0 is 4, and negative 3 minus a minus 1 is really negative 3 plus 1, which is a negative 2, which gives me negative 2 as a slope. And over here, 5 minus 3 is 2, and 2 minus 3 is negative 1, which gives me negative 2 as a slope. So indeed, these two sides are parallel. And I just took a moment to find the slopes of AB and DC to prove that they were not parallel. So these guys are not parallel, so I can confirm that I indeed have a trapezoid. Now to determine whether it's an isosceles trapezoid. Remember the rule we got? We said that if we can prove that this guy and this guy, the diagonals are congruent, then we know it's isosceles. So you guys know what we're about to do? Distance formula. The distance formula. No, nobody wanted it. Okay, so here's the distance formula. So I party along, I did my thing. Here's the distance formula. Oops, gotta have it squared here. And then I plugged in the values, and I got for AC the square root of 37, and for DB I'm getting the square root of 34, which are clearly not equal, therefore not isosceles. Not isosceles. And so it's kind of funny. I looked back just to make sure I was doing everything right, and the textbook chose a different way. They said, well, if it's isosceles, that means two sides are equal. Just prove that these two segments are equal, which was probably, I guess, just as good and probably more direct. But either way, they're not equivalent. This is not an isosceles trapezoid. So there we go. All right, so here's a little bit of chat about the mid-segment theorem of a trapezoid. Remember, we talked about the mid-segment. They're going to define it here for us. The mid-segment of a trapezoid is parallel to each base, and its measure is half the sum of the lengths of the bases. Well, they don't actually define it, but the mid-segment is going to connect the midpoints of the two legs, and then it has some really nice things that happen. So once you create that, its first thing is that it is parallel to the two bases, right? The mid-segment is parallel to the bases, and its measure is 1/2 the sum of the lengths and the bases, meaning it is the average of these two. So AF plus CD divided by 2 will give you BE. So BE is the average of those two bases. Kind of neat. All right. I think we don't have a whole lot of time to go through the rest of this chapter, so I'm going to make it a part 1 and part 2 situation, and I'll see you in the next video. Take care.